Welcome, my dear students, in Prep 3. Today we want to start the first lesson in analytic geometry. This lesson is about the distance between 2 points. We want to learn how to calculate the distance between any 2 points. We will assume that we have 2 points M and N. I want to calculate the distance between the 2 points M and N. In this case, I want to complete the drawing of a right angle triangle in which MN is a hypotenuse of this right angle triangle. Why? Because I want to use Pythagoras theorem to get the length of the hypotenuse MN. Okay, we know that the length of the hypotenuse equals the length of the two sides, the summation of the length of the square of the two other sides. Okay, so the length of the hypotenuse will be ml power 2 plus ln power 2. Look at this figure. ml, this is ml. ml equals, the length of ml is y2 minus y1, and the length of nl is x2 minus x1. Okay, so mn, or the length of, or the distance between the 2 points M and L, will be y2 minus y1 all power 2 plus x2 minus x1 all power 2. Okay, so if we have any 2 points x1 y1 and x2 y2, and we want to calculate the distance between the 2 points, we will take the square root of the square difference between y coordinates plus the square difference between x coordinates. Let's take some exercises. The first one here, I want to calculate the distance between the 2 points A and B. So I will take the square root of y2 minus y1 all power 2 plus x2 minus x1 all power 2. Let's begin. So we have 1 minus 5 all power 2 plus negative 1 minus 2 all power 2. We'll calculate it. It will be 5 length unit. Another exercise, here we have a triangle ABC. This triangle, we have A, B, and C. We have the coordinates of the 3 points A, B, and C. I want to prove that ABC is an isosceles triangle. So I should calculate the length of the sides. If we have 2 sides are equal, then this triangle is an isosceles triangle. The isosceles triangle is a triangle in which 2 sides are equal in length. So I'll begin with the side AB. 9 minus 3 all power 2 plus 5 minus 3 all power 2, and all under the square root. I'll get the first side AB to root 10. The second side, for example BC, here we have 7 minus 9 all power 2 plus negative 1 minus 5 all power 2, and under the square root, so it will be also 2 root 10. The third side will be by the same way 4 root 10. So here we have 2 sides are equal, so this triangle is an isosceles triangle. So if you want to prove that a triangle is an isosceles triangle, calculate the side length if 2 of them are equal. So this triangle is an isosceles triangle. Here is another exercise. I want to prove that the 3 points are collinear. Okay, if you have 3 points and you want to use the distance between the 2 points to prove that the 3 points are collinear, we should prove that the length of, or the summation of the length of 2 of them equals the third. Okay, the summation of the length of the distance between 2 points of them equals the distance between the other points. For example, it means that the 3 points can't be a vertices of a triangle. Okay, so let's begin. Here, for example, we have AB. If you calculate the length AB, so you have the square root of 4 minus 7 all power 2 plus negative 3 minus negative 2 all power 2. It will be root 10. Okay, then BC, we have 16 minus 4 all power 2, and here we have 1 plus negative 1 minus negative 3 it means 1 plus 3, because negative negative is positive, all power 2, then under the root it will be 4 root 10. If you calculate AC, it will be 3 root 10. So here I have 10 root 10 and 4 root 10 and 3 root 10. You can notice that here we have root 10 and here we have 3 root 10. If the 3 points are vertices of triangle, in this case the summation of the two sides should be greater than the third. But here we have root 10 and the 3 root 10. Root 10 plus 3 root 10 equals root 5. So the summation of the length of the two sides equal the third. So this is not a triangle. So the 3 points are collinear. Why they are collinear? Because BC equals AB plus AC. Okay, so the 3 points are collinear. Okay, so if you want to prove that the 3 points are collinear, calculate the distance between each of them. Okay, imagine that the 3 points are for a triangle and calculate the distance between each of them. If the summation of two sides is equal to the third, it means this is not a triangle. The 3 points are collinear. Okay, and that's what we have here to prove that 3 points A and B and C are vertices of a triangle. I'll get AB, BC, and AC, and then I'll prove that the summation of the smaller two sides is greater than the third. If I take the smaller two sides and add them together, they should be greater than the third. If they are not greater than the third, in this case, the 3 points are not a vertices of a triangle. The 3 points are collinear. Also, I want you to remember that to determine the type of any triangle, if you have a side length and you want to determine the type according to angles, in this case, take the greater one and calculate the square of this greater one, and also the square of each of the other sides and add them together. If the square of the greater length equals the summation of the squares of the two other sides, in this case this is a right angle triangle. If the square of the greater length is less than the summation of the squares of the other two sides, then this is an acute angle triangle. If the square of the greater side is greater than the summation of squares of the other sides, so this is an obtuse angled triangle. Okay, let's take some exercise to clarify this point. Here, for example, we have 3 points. We have the coordinates of 3 points. I want to prove that this triangle is a right angle triangle. After I prove that, I want to get the area. Okay, so I want to calculate AB, BC, and AC. Okay, by the same way, by the same rule, I'll calculate the 3 side length. AB will be 5 unit length, BC also 5, and AC is 5. Okay, by the same rule, x1 minus x2 power 2, y1 minus y2 all power 2, and all under the root. Okay, here we have 3 sides, 5, 5, and 5 root 2. The greater one is 5 root 2, so I'll get the square of this side. It will be 5 power 2, 25, and root 2 power 2 is 2, so 25 times 2. So the greater one will be 50. The square of the greater side will be 50. What about the summation of the squares of the two other lengths? 5 power 2 equals 25, 5 power 2, 25, so also 50. So this triangle is right angle triangle. Okay, so I'll calculate AB power 2 plus BC power 2, it will be 50, and also we have AC power 2 is 50, so they are equal. It means that this triangle is a right angle triangle. I want to calculate the area. We said that the area of a triangle equals half times base times height. The base here is 5 and the height also is 5, so half times 5 times 5, which is 12.5. Okay, this is the rule of the area of a triangle. We have the base 5 and we have the height also 5, so half times 5 times 5, which equal 12.5 square units. Okay, if you have 4 units and So we have A, B, C, D, and this is a quadrilateral because we have here 4 vertices and so 4 sides. So this is a quadrilateral. If you want to prove that this quadrilateral is a parallelogram, I should prove that each two opposite sides are equal in length. It means AB equals CD and BC equals to AD. If I want to prove that this quadrilateral is a parallelogram, I should prove that each opposite sides are equal in length. I'll draw it and write in order A, B. You should write the vertices in order C, D. Okay, so you can get the length of AB and the length of DC, they should be equal. Then you will get AD and BC also, they should be equal. If that's right, so this is a parallelogram. Okay, if I want to prove that this quadrilateral is a rhombus, in rhombus all sides are equal, so I should calculate all the side length and they should be equal in length. If that's right, so this is a rhombus. If I want to prove that this is a rectangle, I'll prove that each two opposite sides are equal in length, so this is a parallelogram. And in addition, I want to prove that AC equals BD. We said before that in rectangle, okay, the diagonals are equal in length, so I'll prove that each two opposite sides are equal in length and also the diagonals are equal in length. AC equals BD, and of course AB equals CD and BC equals AD. Okay, this is if I want to prove that this is a rectangle. If I want to prove that ABCD is a square, I want to prove that all sides are equal and also the diagonals are equal in length. Here, for example, I have 4 points. So this is a quadrilateral. I want to prove that these points are vertices of a rectangle. And then I want to get the area. Okay, what can I do? If this is a rectangle, so okay, let's draw a rectangle here, for example, and we have the 4 points. I want to prove that AB equals DC and BC equals AD. So I'll calculate each of them by the same rule. Okay, the square root of difference in y all power 2 plus difference in x all power 2. The first side AB is 2 root 10. By the same rule, DC will be 2 root 10 also. AD is root 10 and BC is root 10. So we have 2 root 10 and DC equals to AB, and also AD equals to BC. And in addition, until here, this shape or this quadrilateral is a parallelogram. I want to prove that this parallelogram is a rectangle. We all know that rectangle is a special case of parallelogram. So I should prove that the diagonals are equal. BD equals to AC. So I'll calculate BD and AC. So this is a rectangle because they are equal. BD is 5 root 2 and also AC is 5 root 2. Okay, so if I want to calculate the area, and here we have and find its area. Okay, the area equals to length times width. Area equals length times width. The length here is 2 root 10 and the width is root 10. So here we have 2 root 10. This is the length and the width is root 10 multiplied together. So the area is 20 square units. Okay, 2 times 10 is 20 square units. Okay, let's continue. We studied before that if you have a line segment, any point on the axis of symmetry is equidistant from the terminals. Okay, so if I want to prove that any point M lies on an axis of symmetry of a line segment, I should prove that MA equals MB. Here, for example, in this exercise, I have A and B. I want to prove that point C lies on the axis of symmetry. It means CA equals CB. So I'll calculate the length of CA and the length of CB. The two lengths are equal, so point C lies on the axis of symmetry of the line segment AB. Okay, so this is another proof. We can use the distance between 2 points to prove that any point belongs to the axis of symmetry of the line segment. Okay, here also we have another proof. If you have a circle, if A belongs to the circle M, then the radius R equals MA. Here, for example, this is a circle. The center of the circle is M. Okay, the radius, if A belongs to this circle, it means that MA is the radius. Also MC, also MB, because any point belongs to the circle is equidistant from the center, which is M. So A belongs to the circle M, then the radius R equals MA. If C belongs, so the radius equals MC. If we have 3 points belong to the circle, it means MA equals MC equals MB. Okay, so we can prove that a point belongs to a circle. I want you to remember the two rules of calculating area and circumference of the circus. The area equals pi r power 2 and the circumference equals pi d. Pi r, what is r? R here is the radius and pi is 22/7. The circle of the circle, the circumference of the circle equals pi d. It means 2 pi r because the diameter equals 2r. Diameter equals 2r, 2 times radius. Okay, the two rules here are so important. The area of a circle is pi r power 2 and the circumference of the circle is 2 pi r. Let's take this exercise here. I want to prove that the points A, B, and C lie on the circle whose center is M and M equals 2 and -3, and find the circumference of the circle in terms of pi. In terms of pi means don't change pi, don't substitute instead of pi using 22/7. Leave pi as it is. Okay, if the 3 points belongs to this circle, it means that MA equals MB equals MC, as we said before. So I'll calculate MA by the same rule, 5 length unit. I'll calculate MB and I'll calculate MC. As you can see here, you can calculate it yourself. Okay, as you can see here, the 3 lengths are equal. So MA equals MB equals MC, and this is the radius of the circle. So R here equals 5. Okay, so MA equals MB equals MC, then the point lies on the same circle M. I want to calculate the circumference. The circumference equals 2 pi r, and here r is the radius, is the distance, which is 5 length unit. So it will be 2 times pi times r in terms of pi. So don't change pi, don't write 22/7 because here I wanted in terms of pi. 2 times pi equals 10, 2 times 5 equals 10, and so 10 pi of course square units. Okay, so here we have the radius of this circle. How can we calculate this radius? As we have before here in this exercise, we proved that the 3 points are on the same circle. MA and MB and MC all are the radius. Okay, so I calculate the radius equals 5 length unit. Okay, so I have the radius. I want to calculate what? Circumference, 2 pi r. Okay, 2 times pi times r. What is r? The radius. The radius is 5 as we calculated before. So here we have the radius, 5 times 2 equals 10, and I'll put pi as it is, and of course square units. Okay, so square, no, this is length units because this is not an area, it's a circumference, so length unit. Okay, if I want to calculate the area, it will be square unit. Okay, prep, so we can calculate the circumference of the circle. We prove at first that the circle the 3 points belongs to the circle, then we prove, then we use r, which is the distance between the center and each point of them, which is the radius, equal 5 to get the circumference using the rule. Okay, so today we studied how to calculate the distance between any 2 points. We solve more exercises about how to use the distance between 2 points to prove that, for example, the triangle is an isosceles triangle, or also the 3 points are collinear, also to prove the shape or the quadrilateral is a rectangle, and also 3 points belongs to the same circle. Okay, I hope you have understand our session today. That's all about our session. Next session we will study how to get the 2 coordinates of the midpoint of any line segment. Thank you very much for watching. See you next session, and goodbye.